So I'm going to go ahead and start the presentation. If more people come, then we'll go ahead and let them in. And welcome to the users group. This is a big day for me because we have been running this group now for a year. And when I started the group, I'll tell you how it started. Was we were supposed to come back to work, and my wife looked at me, and they canceled it because COVID got bad again. And my wife just looked at me, boys, you've got to do something different. And so I said, I still started a users group. And at that time, there was another AWS users group that was running in Cincinnati, and they had 200 members. And they didn't seem to be that active. So I thought, well, maybe in a year I could have 200. And we're at 402. And and we're growing. There's been an acceleration in growth. So very thankful for everyone who's joining and being a part. Everything is free. All these resources are free. You get to be my age, you just want to help people, and that's kind of where it is. And you will not be charged. And I will be talking a lot of products, but I don't work for these people. They just work well for me. And you may have other products, and sometimes I learn a lot more from people than I think I teach them. So if you have an idea or you work with a certain product that you think is better than this, or you've got another way of doing it, feel free to share it with the group. I encourage that. All right. With that said, we have a number of events coming up, which I'm excited about. Of course, today is getting started with Kubernetes. And I had put originally that we're going to do some Terraform. We will not be doing that today, but when we get to the next topic, Terraform and Google Cloud Certified Associate Cloud Engineer, we will be addressing that. And we'll also be doing a Terraform Google example, a Kubernetes Google example. Kubernetes runs really well with Google, of course, because they were the creators of Kubernetes. We have acing the AZ500. I may move this down and put another Kubernetes in here, specifically preparing for the developer's exam. So we'll discuss that today. So this topic here may move. Passing the AZ700, really looking forward to doing this networking exam. In fact, all this Kubernetes stuff really helps because Kubernetes really its services are all about networking. AWS Professional Arc Exam, cram session, that's right. The Arc exam is going away. The professional one is being retired. And a new one, of course, will be coming in its place. And if you're familiar like I am with AWS exams, the newer ones are always harder. So if you're going to take the AWS professional exam, this is the one you want to come to. It'll be 2 hours of cram. We'll be going through problem after problem. Ask Charles. I can really lay it on you. Charles has passed the pro. He was in my class. So with that said, next we'll be doing the AWS Certified Security Specialty exam. We'll be going through that and passing that exam. Creating the AWS Crypto Bot. I moved that one because crypto was tanking, and we'll see how it's doing in December. I definitely want to teach you employable skills. Right now, crypto is not an employable skill, maybe one we may delay again. And then we're becoming an Azure Solutions Architect. I love taking these architect exams. They are difficult. It takes a lot of study, but I love showing you how to pass them. Okay, with that said, that's what's coming up and coming down the line. Let's go to the next slide. Oh yeah, there's hot technology
there, Mike.
Yeah, I know. I mean, I'm all planned up, and I'm gonna squeeze.
I love it. Love it.
I'm gonna squeeze some more stuff in there. So this is just the framework. and I gotta tell you, I'm a little bit selfish because it kind of corresponds to some of the exams that I'm taking. I do about an exam every month, and I'm really clobbering them. And so I do a lot of research to get to that point, and I've been taking these for years, and so I like helping people pass these exams. This is one kind of step up the ladder as they move forward to better careers. With that said, there's a lot of technologies out there that are really hot. Kubernetes, Terraform, Azure, AWS, really hot technologies. And you can see a lot of people signed up for this group because they've heard the word or they're interested in learning more about Kubernetes. Today, we're going to do the icebreaker in my standard demo. We're going to talk about what is Kubernetes. We're going to give you some getting started, some examples. I'll be showing you my command line and how I got it installed, and questions and next steps. Right. With that said, Mike's standard intro. Yes, our technical DNA is changing, and it's been changing all along. But no longer do we actually remember facts. We just remember where to get them. So, and one of the big changes coming down the line, disruptive technology will be cryogenics, supercomputers, quantum computers, excuse me. And the reason being is they run at a chill minus 272 degrees. And so your average data center is not going to have a cryogenic cooling system. So you're going to see this is going to be really kind of tighten up on who can do this technology. And once this technology comes out, then it's going to create new experiences. And not only will it make you more efficient, everyone's going to want that new experience. And we've already seen how these disruptive technologies shut things down overnight. So anyway, you can imagine, like yesterday, I mean, it's the same thing about to happen to us in coding. Like yesterday had these room full of women, they're stitching with hands. I'm sure these guys thinking there's no way that a sewing machine or a machine could actually do what these people do. And the next day you walk in and the room's completely empty and they have 10 sewing machines, right? And you're going to see the same thing with coding. I mean, AI is going to start taking over and doing the stitching. If you don't believe me, 5 years ago, and now 6 or 7, AI actually beat humans in reading comprehension. So there you go. It's coming. Natural language processing is zipping along. It won't be long before machines are coding for us. With that said, there's been an interplay of just the technology that's been changing underneath us and the things we could actually do as far as coding is concerned. And so as the technology moved forward, then you had different languages come along. Like, I started in Fortran, right? Or in BASIC and Fortran and punch cards. And then we had Java and then C# and then, JavaScript and Python and all these promises of scalability. And it was going to be the next new thing. And all of them kind of fell flat. The one technology that has not fallen flat, that has promised what it was going to deliver, is cloud. We're going to give you a system that's going to be worldwide. It's going to be, inexhaustible. It's going to be, in seconds, and all those things are happening. So, and true, and on that platform, we're starting to hear things about no code and low code systems. And a lot of that is riding on what's called a FAAS, or function as a service. And what that is, it's a container that's coming up, processing a piece of data, then going back down. So there you have it. And that's containerization, and that's what we're going to talk about today. Before we get there, I want to give a call out to Code Cloud Engineer. I am not being paid by Code Cloud to advertise them, but I've talked about this group a bit. And one of the visions I've had is that maybe somewhere down the line, we may create something like a business incubator, something where people can get experience. Because what happens is you come in here and you get a lecture, right? You understand the basic concepts. And then you do some labs, you do some hands-on, you get some practice. I think you got that. But if you don't really apply it in a real world situation, what do? You just forget it. So you want to get some experience in hands-on. What Code Cloud is trying to do is create what's called a Code Cloud engineer. They have a real project you actually get involved in. You don't get paid for it, but a real project you get involved in. And you actually get some kind of real hands-on experience. I'm trying it out to see what it's like. And I actually did my first project and I actually skipped it to see what my supervisor would do to me. So I'll show you Code Engineer real quick. You can sign up for this. And I think this one's free. And you can see that they have a dashboard that shows my experience and all the tasks I'm completing. And it's basically dedicated for becoming a DevOps engineer and becoming employable in the community. And I skipped my task, and my supervisor, he didn't talk to me for 2 days, but then he gave me another task. So I can go, and my next task is to do something with Linux. So there you have it. So if you're interested in something like that, but it would be nice if somehow this group could actually do something like this, but actually get paid for it, or like work for a nonprofit or something, so you guys can get experience for what you're learning. So it's in the back of my head. If anyone comes up with a great idea as far as how we might create a business incubator so you guys can get real hands-on experience, let me know. It's certainly something I want to do down the future. Maybe this time next year, we'll have a business incubator. But Code Cloud is thinking the same thoughts, It's not enough to just get a certification. We need real world experience. Okay, it's time for the icebreaker. All right, think about this, guys. If offered $1 million, could you give up your cell phone for a year? Okay, most of us might think so. If yes, on a scale of 1 to 10, where 10 is the worst, what would be your pain factor? All right, I guess is what you grew up with. Thanks so much for your comments. If anyone has any more comments, please put them in the chat, and maybe we'll get to them toward the end. But we got a lot of material to get through, so let me go ahead. I love these icebreakers. Okay, with this said, infrastructure as code. It's called IAC. So infrastructure as code tools allow you to manage infrastructure with configuration files rather than through a graphical user interface. So, I mean, when we teach the cloud and you're starting off, you start off with a GUI, right? And you go in there and you create servers and you do all this work. But if you're dealing with like 5,000 servers, that's just impossible. So you need some type of infrastructure as code system. And there's a lot of them out there. And so let's take a look at that real quick. You might see charts like this. And so you've heard of stuff like Ansible and Puppet and SaltStack and then Docker and Kubernetes and Packer and Vagrant and Terraform and Cloud Formation. You go, what's the difference? And if you get in there and you read the literature and you read about Ansible and you read about Terraform, they seem the same, but they're not. They're on two total different spectrums. And so same thing with Kubernetes. I mean, what is that? And so we're going to talk about that and why that's important and how to get started with Kubernetes today. But basically, it began with something called Docker, and we're going to discuss that here in a moment. So where did Kubernetes come from and what is it? Kubernetes is an open source container orchestration system for automating software deployment, scaling, and management. It started from something called the Borg. It was a project at Google, and it's how they manage thousands of servers. And if you're familiar with, what is it, next, the Voyager, they were always running into the Borg people. So it came from the idea of the Borg cube. Well, the people who created Borg decided to create an open source project called Kubernetes. It has a lot of the same things that Borg did, but a lot of upgrades as well. I think now they have like 28,000 people working on Kubernetes. So you can see it's hot as it can be, hot technology. With that said, you often might hear the name K8, and the reason they call it K8 is because there's eight letters in Kubernetes. So kind of cute. Kubernetes is a declarative language, and what that means is you describe the end state, not the way to get there. So I really love state systems, and so Terraform's a state system. You tell them where you want to be, and the system figures out how to get there. And it varies so much. If you've done any artificial intelligence is a state vector system. So if you love that type of thing, like I do, and you'll read about that, just keep that in mind. Just a few things about Kubernetes. Applications run inside containers. Containers are grouped by pods. A node is a host, and a cluster is a group of nodes. And we'll explain what all that is as we move forward. All right, and a few things about top reasons to adopt Kubernetes. So in the old days, and you guys have been around like me for a while, you'll remember when you got a piece of software, it might not run on your machine. So what you had to do was install other things to make it go. Do you guys, anybody remember that? Charles, do you remember those days?
Yes, absolutely.
Yeah. And
Absolutely.
we get a piece of software, it was the hottest thing, but we'd spend like what, 4 or 5 weeks trying to figure out how to get it to run on our machine. And what Kubernetes and containerization does is that it runs the same on all machines. And so we'll get into why that's true. And so that seamless migration to the cloud, right? Multi-cloud flexibility, improved scalability and availability, cost optimization, faster time to market. All these are reasons to adopt Kubernetes. Doesn't really describe you what it really is, but here's another reason. A lot of people are using Kubernetes to create microservices. And so what the heck is a microservice? So once again, for the older guys, we're all used to something called a monolith. What a monolith is, we create these conglomerate programs that just got bigger and bigger and bigger. And as they got bigger, they were all kind of like non-linearly connected. If you change something over here, then it would break something over there and you wouldn't know why. And so as the monolith got bigger and bigger, it actually got slower and slower and harder to program. So the idea a number of years ago, along with the DevOps movement, came the idea of microservices, decoupling your system into a lot of smaller services. So if you had to change something, all you had to change was that service. And now that's really caught on. And a lot of things are being API driven because you can decouple them, and you have to change something that you just change that piece and not the whole thing. Now, we all make this sound easy, but really you're still scaling. You're just changing the marbles, right? So everyone has the same bag of marbles, they're just arranged differently. So I wouldn't say, oh, I'm going to do microservices and all your problems are going to go away, because you got to have good microservices. So if you have a monolith, try to solve as many problems as you can before you go to the microservices, because you could go from a big boulder to a big bag of dirt. So it's still a challenge. I think programming is still challenging, but what microservices buys you is a decoupling, and Kubernetes can be run on microservices. So how did this whole container thing start? So in the old days, when you bought a server, right, you could put a program on it, and that was exciting. But we wanted to do more than just put one program or one operating system on it. So we created, on top of that, a hypervisor, which allows us to create virtual machines. And each one of those virtual machines had its own guest operating system. The problem with that is these guest operating systems were heavy and large and took a long time to bring up. And so the idea came along to actually create something called a Docker engine, which allowed you to run off the host OS. So you didn't have to install all these OSs. And it turned out that it came up really fast, right? Really fast. And that's where we get function as a service, which is bringing up a Docker container and bringing it down. And not only that, once you put a program in this Docker system, you could put it on any machine and it would run the same. And that was a big, wonderful thing that happened. And so suddenly now we would have all these applications that needed to talk to each other, and we just put them in containers and basically hook them up so they could communicate with each other. My biggest question when I got to Docker and started working with the Swarm, how do these machines talk to each other? And then Kubernetes, they use services, and we'll get into some discussion about that. But the big thing that made Docker the most famous and that launched it was the Docker Hub. And what was so cool about the Docker Hub is that you could actually go there and get containers created by other people. All right, so if I came here and I say, well, I need an Nginx container, I could type in Nginx, and there it is. And so I don't even have to create my own containers. I can just pull them off the hub. Now, there's one caveat here you gotta be very careful about, and that is security. You need to make sure these containers are vetted. You don't just go out there and put any container on your system because it could have security holes, or a bad actor could create a container you think that you really need, and you put that container on your system, it could have holes in it. So be careful with containers, and you need to have a registry that kind of that validates those containers. And so keep that in mind. But it was Docker Hub that really launched Docker, because now you had all these containers that were being worked on by the community that you could immediately download to your machine, and you're suddenly up and running Nginx or running MongoDB or running whatever you need to. Yeah, it was like automagical, and we're going to do a demo of that right now. So let me go ahead and pull that down. And I think we're going to do a demo, or we may be talking about how to get to the demo. Let me see. Oh, we're going to do a demo, right? Okay, let's do one right now. So I have two systems running on my local. I have Minikube, and I actually have Docker Desktop running on my local machine. I'm going to use that to actually show you how to just immediately create a pod. And we're going to talk about what pods are, but pods are basically the basic container for actually not the basic container, but actually the unit that you put containers in. So right here, I actually have Minikube running on my machine. Matter of fact, I have more than Minikube. Let me go ahead and clear this so you can see the screen. Can you guys see my screen?
Sure, yes, we can.
Yes, we see.
Excellent. So what I'm going to do here is I'm actually going to show you something. I have something called, it's called kubectl. And what kubectl is, that's the Kubernetes CLI that's going to be used to talk to Kubernetes with. And so if you want to know more about it, you can do a .h, and that'll give you all the help on kubectl. So that -h will be very important for you when you start to take the exam, because you'll have this, and if you want to figure out how to run a command, you can just hit -h. You can also use the Kubernetes docs during the exam, and we'll talk about how to use those as well. Okay, so what I want to do is I showed you the Docker Hub, and I showed you that the Nginx was there. Let's just go ahead and create a pod in Kubernetes and show you how easy that is. Now, before I do that, there's one thing you might want to do, and that's create an alias. All right, you can type in kubectl, or you can type in K. All right, and so you're going to see lots of times I'll type in K because I've created my alias. Now, how do I know what alias to create? Well, it turns out that if you go to the Docker, the Kubernetes docs, they have a cheat sheet. So let's go there right now. So I'm just going to go the way I would go as if I was just a regular person, right? So if I'm going to go right here into, see if I can bring up this and see if I type in Kubernetes. Let's see if we get some docs here. And there's a Kubernetes documentation right there. And you can use this on the exam. And then if you type in cheat sheet, and that comes up, you can see in the cheat sheet right here, going to bring that up, it has lots of commands here. And the first two commands, this shows you how to get autocomplete working, and this shows you how to set that alias. All you need is a K, as opposed to typing in kubectl. It saves you a number of keystrokes, and you may not, it may seem kind of weird at first, but then once you start just using K to do all your commands, you go, oh, I like this. So I'm going to maybe put K in there every once in a while because I already set my alias, but we'll start with kubectl. So the first thing I want to do is just create a pod, and you can see the command here for creating a Kubernetes pod is kubectl run, and I'm gonna give it a name. I'll call it Mike's Nginx, and then I grab that image. When I say image equals Nginx, what's going to happen there? Anybody know?
It's
It's
going
going
to use the Nginx image.
It's gonna go and pull that
Docker
Nginx
Hub.
off of that Docker Hub, you bet. And it's gonna put it right into my pod and it's gonna crank it up and run it for me. That's how fast I'm gonna have an Nginx running on my machine. Now, if I was to go to my hosting service, right, and ask them, okay, I need to set up a server, I need to get Nginx running and all this stuff, how long would that take?
A lot longer than this is going to take.
Thank you, Charles. And if I didn't oh, my pod's up and running. There you go. So how do I see that pod? So if I want to see that pod, I'll go ahead and clear you guys, bring this all to the top of the screen. If I want to see that pod, all I have to do is go a get, and I go po for pod. Okay, so it's gonna get my pods. I have a few pods running here, but you can see that the one I just created was Mike's Nginx, and you can see 1.1, which means I wanted one and it's running. So we're working well. So that's an example. I immediately got that up and running. It pulled it directly from the Docker Hub, and I got my Nginx going. Okay, with that said, I think I got off my screen here. Let me see what else I want to show you. Okay, so that's gets pods. I'm going to show you how to get more information. Say I'm really interested. Go ahead. Do you have a question? Okay, so if you're on the exam and say, I really want to know more about, a particular exam, I know I need to get, but I don't know how to do that. So I might hit kubectl.h for the exam, and it'll show me all the potential commands I can use with get h. You see that with get. So if I go in here, you can see,
I have a question.
Yeah.
So I use Docker for my home personal server. I just was curious, what's the advantages of using Kubernetes versus Docker?
I
Or
think
maybe I'm understanding it wrong.
Oh, no. I mean, what's going to happen is you're going to see that Kubernetes is going to give you a lot more. There's a number of I actually use Docker for years as well. So so I get that Docker runs inside of Kubernetes. So it's a container system that runs inside of Kubernetes. And then what Kubernetes is going to give you is a lot more communication and easier work with getting all the containers orchestrated together. So it's really
because I
it's the orchestration. It's the orchestration piece that's actually won out over Docker Swarm. Yeah.
Okay. Yeah, because I've seen or I have a list of containers as well, but it's all in Docker. It's not in a Kubernetes environment.
If you're orchestrating and you're doing a lot of orchestration, you're gonna win out with and you're running a lot of workload. You're gonna win out on Kubernetes. And there's a much.
Yeah, I'm looking online. I mean, it says here, difference between the two is that Docker is about packaging containerized applications on a single node, and Kubernetes is meant to run them across a cluster.
Absolutely. That's
okay.
That's orchestration. That's orchestration. So basically, within the pod, you have a Docker container running. Okay. And that pod allows you to orchestrate and get all those containers talking together. And so we're going to talk about that as we move on. But that's a good question. Thanks for asking.
Also, a lot of flexibility in auto scaling as well.
Yeah, absolutely.
So you're saying that my web server I run can also, so Kubernetes can be used as like a load balancer. Like I can have the same web server run on a different node. Say my primary web server on my Docker container goes down. Can I use Kubernetes? Okay, that's what I was wondering. If there's
so if one of your pod goes, let us say you are saying you wanted 3 containers for your web app. So it will spin up 3 containers, and one of it goes down for any reason. The Kubernetes orchestrator will identify there is a control plane that will identify one has gone down, but the required state is 3, but it has only 2, so it will spin up another one. And also based on the rules that you have written, if your load increases, it will spin up more pods.
There are many scenarios in which you can do this in. I will demonstrate replica sets today. And so when one goes down, another will come up. We'll show that. But also you can use the cloud load autoscaler with Kubernetes, but it's expensive. Okay, just want to let you know that. So with that said, I just want to show you a few of those commands, and we're going to move on to the next demonstration. So yeah, thanks you for that explanation too. Who was that, by the way? Thank you so much for
Anthony.
Thanks. And the other guy who was that you, Ram? Or
Hi, yeah, this is Ramesh.
thank you so much for your comments. Appreciate it so much. All right, with that said, let's move on. Let's see where we're at. We did a little demo here. Okay, so now I want to talk about install on your local. When I'm prepping for this exam, I really like to work on my local as well. So I may be listening to a tutorial or something, so I'm typing in, doing commands as well. There's two good options for your local machine. One is Minikube and one is Docker Desktop. Now, let me say this. I actually bought a Mac specifically so I could do Terraform and Kubernetes. And Minikube runs really well on Mac, okay? And I remember when I first tried to learn Kubernetes, I kept trying to get, and this was before, trying to get Minikube installed on my Windows, and it was almost impossible. And since then, they've gotten like a Linux kernel that runs in Windows, and that actually works really well with Docker Desktop. So if you're going to try to run Kubernetes on your local, so you can just practice and prep for the exam, then I would suggest for Windows that you use the Docker Desktop, and then in that Docker Desktop, there's a Kubernetes option, and turn that on. If you're going to use a Mac, then Minikube actually seems to work really well. I actually have both running on my machine. I'm going to show that to you right now. Here's my next demo. Okay, but here are some of the steps you need, but there's a few steps you need to go through to install Windows on your machine. Here's a link for it. And I had to select Kubernetes, and then I had to install the Linux backend. And in my particular case, I had to install the kubectl as well. So, but it works. I've had a few of my interns install it, and they're running Kubernetes as well on their local machines. All right, with that said, let me give you another demo, and I'm going to show you what I have running on my machine, so you can look at that. Okay, so let me bring that back up. Okay. All right, let me bring up I got this in the way. Let me move this a little bit here. I need to move a few things. Sorry about that, guys. Here we go. Bring up my terminal. So let's go and clear this and bring it to the top. And then when I want to see what I'm actually running. So if I go K, I'm going to use K for this example. I'll go to config. And then I'm going to hit get context. And what that's going to do is show me all the nodes that are running on my machine. And I actually have two. I have a Docker Desktop. You can see that. And I have Minikube. Okay, so and you see the star means that I'm running Minikube. So if I go K, or you can do kubectl, okay, same thing. And I go, okay, well, let's look at the config again, and let's use context. Maybe I want to switch to the Docker Desktop. So I can go use context, and I can put Docker Desktop. And now I can be running in that Docker Desktop. So if I see it switched, and if I go back and look at the context, and now I'm see where the star is. Now I'm running on the Docker Desktop. Let's go back to use Minikube. Okay, so you can run either one, but what you're going to want to do is when you run Minikube, and I'll show you here in Docker, you want to turn off Kubernetes. And when you run Docker Desktop, you want to make sure Kubernetes is turned on. Okay, so let me show that to you real quick here. Let me see what the context is now. And now I want to switch context back. Let me go back to Kubernetes, or to Minikube, excuse me. There you go. And that switched context, and you can see the context has been set back to Minikube. So if you're running, so I can run either on my Mac, I can run either desktop or Minikube. And if I want to run the Minikube, then I want to make sure that the Kubernetes is turned off, because it seems to get in the way. And if I want to run the Kubernetes, I'm on Windows, for example, you want to go here and make sure you turn Kubernetes on. Okay, and that way you can run desktop and Kubernetes. So it's really nice now. It's not as hard to get Kubernetes up and running on Windows anymore. Just install the Docker Desktop and then just click on the Kubernetes option, and you're up and running. Okay. In this case, I have both on this Mac, so I can run either one. All right, cool. And so that should get you guys up and running. I suggest as you do tutorials, as you go through the web, that you not only use the environments that they may have, but you also typing it in and using your local, and that gives you more room to experiment. With that said, let's see here. There's lots. We showed you the Kubernetes documentation. You can use that on the exam. That cheat sheet that I showed you, become very familiar with that and learn those commands. That will help you tremendously on the test. With that said, if you don't want to use an environment, say you don't want to install anything, or maybe you don't have the money, or maybe you can't get it working on your machine, there's an interactive environment that you can go to and run it. Okay, so there's a number of tutorials on the Kubernetes documentation site. So if you click here, you can actually run a system that will actually run Kubernetes for you. Okay, and you can go through an entire tutorial and step through it and learn how to do some Kubernetes programming there. So a lot of resources for people to learn. There you are. And so if I go get pods, so kube kettle, get pod or pod, you can see get pods, you can get pod, get po, same thing. And it says the connection to the server didn't work. So wow, let's see, what did I do wrong here? Oh, it's a Minikube. Let's see what got, let's see. Oh, I need to start the Minikube. Okay, I didn't start Minikube. So in this environment, you have to start your Minikube, okay? And then Minikube will start up. And then, so because this one's running Minikube, and then you can actually do your Kubernetes commands. So make sure if you're running Minikube, you start it, and then you can stop it when you're done with your stuff. All right, so if you're interested in not installing Kubernetes on your system and you still want to learn it, well, you can do it through this environment here. And I'll show you another environment as well that you can learn Minikube from that you don't need to install. Okay. All right, we'll get off of that. I just want to make sure I show that. Cool. Leave that site. All right. With that said, there is on the Kubernetes documentation, there's training materials. So let me go over those real quick. We'll go ahead and bring that up. All right. Okay, so there's a lot of training resources on the site, and they have suggestions for how you can get trained. Now, right here, there are 3 courses that they say are introductory courses. One is Introduction to Kubernetes, one is Introduction to Cloud Infrastructure, and one is Introduction to Linux. They're taught through edX, and the courses are free. So if you can go to those courses, you can actually go through and go through those courses. You can choose the certification option. If you do that, the certification option is not free. And for example, this Intro to Kubernetes, the price was $169, I think. I actually took this course. It's kind of pricey, and it was pretty heavy text-based, but I actually learned some stuff. So if you're brand new to Kubernetes, maybe this is the direction to go. I'm going to show you a cheaper option, but yeah, if you need a certification real quick and you don't mind which one it is, you may go for the easy exam just to get your feet wet. So that is one I actually just, of course, I teach this stuff. So I like to see what other people are doing and what I can learn from what they learn. And so I actually did this exam or not. I will say that I made a 99%. That's pretty ugly. I want to talk a little bit about, philosophies in an organization. This question often comes up. How much do I need to know to be considered an expert in a technology? Can anyone tell me how much I need to know to be considered an expert in a technology?
You need to know where to find the answer.
Where to find the answer?
Well, I always thought it was you had to travel more than 50 miles and carry a briefcase.
That's called an expert, right? It has been from somewhere else, right? How much do I need to know in my IT organization to be considered an expert in a particular technology?
Is there such a thing?
Just a little bit more than the other guy.
10% than anyone else.
Yep.
And then you got to make sure you continue with that 10%, right? And then there's the halo effect that happens in industry as well. Does anyone know what the halo effect is?
Yeah, basically when you pop your head out and say you know a technology, all of a sudden you become the go-to guy.
If someone's good with one technology, they're definitely good at all of it, right? So glad you recognize those. So anyway, here's a few things real quick here just to talk about some of the certifications that are out there. They have the cloud native certification, which is called the KCNA, which is once again a question-based technology. They have the certified Kubernetes application developer and the certified Kubernetes administrator developers. These are hands-on certifications, okay? And I'm going to show you some really good sites of where to actually get prepped for these 2 exams. This is what I would call your Kubernetes engineer. This is where you want to be. And then there is the CKS, which if you're interested in security, these are the certifications. This is certification you want to get for security and Kubernetes. This is extremely important, and you find this is very important in Terraform as well, because they have something in Kubernetes called secrets, and it only encodes 64 bits. So it's easy to decode, so it's not really a secret. You've got to handle this security piece. With that said, the top 3 courses for Kubernetes, which if you do get on the web and say start prepping for this exam, and you're gonna see these 3 courses over and over again, are the courses created by Momshad Manabeth, if I said his name correctly. And these are all hands-on, coming through Code Cloud. As a matter of fact, Momshad Manabeth was the creator of Code Cloud, released his first course in 2018 created Code Cloud in 2019 and has continued to work on it. And I've actually visited and been on the site, and it's a labor of love. He has really done a good job of it, and it can really help you prep for this exam. We're actually going to look at it, and I'll take you to it and I'll actually do some work on it so you can see it. With that said, when you install a Kubernetes pod on your system, you're installing a number of things: an API server, an etc server, a Kubernetes server, a container runtime, a controller, and a scheduler. So basically, going up from the bottom, scheduler basically decides when you distribute the work. A controller is going to make decisions to bring up new containers in such cases. Container runtime, that's your Docker. Okay, it could be Rocket, could be another container, but it's going to be the system that actually someone mentioned they're running Docker. Well, that's what that's going to be. A Kubernetes server is going to run on each node in the cluster. So you have nodes and you have a controller or a master. And we'll discuss that in a moment. The etc service is distributed reliable key value storage, basically going to store state of your system and will help you manage your cluster. So if your system goes out of state, it's in the etc what it should be. It's going to try to bring it back into state. And the API server is what everyone loves, because from that's how you're going to use that kubectl, the command line, to discuss and to talk to the Kubernetes cluster. All right, real quick, that's what it is. This is what it kind of looks like. These nodes are worker nodes. They used to be called minions. I guess that name has fallen out of vogue. But and then you have a master controlling it. Now this is very similar to the Docker Swarm. And what Kubernetes will allow you to do too is distribute that load. So you can put labels on there and tell them and taint it and tell them where the different workloads should go. So that's a big improvement, because when I ran the Docker Swarm, you could not. There was an algorithm, and many times it would just pile up on one node. That node would crash, and I'd have to rebuild it. And so that's a big improvement. With that said, the master, you can have more than one master, and you want to, because if any one of these servers goes down, another server should take its place. Okay. So basically what you have is you have a server, and when you have a node, and in that you're going to have your pods, and you're going to stack your pods up. All right. With that said, the fundamental building block of Kubernetes is a pod. So pod is a unit of scheduling in Kubernetes. It is a resource envelope in which one or more containers run. So you can see in this particular instance, we kind of have this pod, and I got to tell you, when I did the Docker Swarm, I did Docker, I was going, what the heck is this pod stuff? I mean, this is too confusing. And then once I learned Kubernetes, I went, hey, you know what? I wouldn't do it any other way. And so basically these pods are going to group basically containers. They typically don't want a huge amount of containers in one pod. You want the pods to be limited to the number of containers that they hold. Okay, so containers should only be scheduled together in a single pod if they are tightly coupled. So maybe you need a database, for example, with a container. So you might put that in the pod with it. Typically, you want to run some of that data outside that pod, because if it crashes, then you lose everything, right? With that said, if you're starting to work with pods, we're going to do a little demo here. There are certain technologies that you really need to learn, that you need to master. You need to know a little bit about command line, and maybe a little bit of Linux, okay? You need to understand the VI editor, or maybe you could use VS Code. You need to understand what YAML is and JSON. So basically all the stuff you're going to be doing in Kubernetes is YAML, but then that gets packaged into a JSON that goes to the API server. And then you need to know a few about Docker basics. So I was thrilled to see what happened in the cloud with Docker and containerization. I mean, it was amazing. Suddenly we just, like overnight, the cloud went to containerization. And same thing with AI. With AI, you're running all these different systems, and suddenly overnight, Kubernetes became the choice product to run artificial intelligence on. So it was really, I mean, this technology has really taken the cloud over. So I want to do a few examples here. I do a little bit more demo with running Kubernetes. And the first thing I want to do is go back to kpods and get information on the pod we just created, and show you the -o wide command. Let's do that real quick. So once again, go ahead. Someone got a question? We'll use kgetpo, and if you look at that, you can see you get this much information. But if you want to get more information for an exam, you can do -o wide, and that gives you just a little bit more information. Show you some IP addresses, and then a little bit more information, what node it's running on. You can see everything in this case is running on Minikube. Okay. If you want even more information, then you can use the describe command, kdescribe. And I'll show that command to you so you can see that real quick. Let's see, do I have it down here? Kdescribe the pod in my name, but then you can actually pipe it into a grep. So say I got a pod and I want to know in the exam what image it's running. So I could go K describe. Let's get the rest of it here. Put pod because I want to get a pod. The name was Mike something. Let's see if I can do an autocomplete on that. Where it is. Mike engine X. And then I want it to get and then I can do a grep on that. Okay, let's go and do a grep on that. Something's not right. Let's just do a grep on it anyway. Let's grep. I know I got a mistake here somewhere. I fat finger stuff all the time. Let's do image. Let's see if we can get anything. Yeah, I'm grep something wrong. Oh, okay. So look at that. Looks like I did it right. And it says it used Nginx, I guess. Yeah, images in Nginx. Something doesn't quite seem right about what I just did. Okay, describe pod, Mike's Nginx. Okay. Well, it doesn't quite look like I think it should look like, but if you want to find out more about without using the grep, then it's going to give you a lot of information about what's actually in that. And so you can see there's a lot of info here about that particular pod. And when you're taking the exam, they'll often ask you a question and you're going to want to hit that describe and go in there and maybe pull out why it's working or not working. So if I come along here and I want to go, well, let's create a new pod. Okay. And so if I go K run Mike's new pod, right? And I want to give it a image, and I make that image engine X12222. It might create that pod, but if I now want to go take a look at that pod, go get pod, get PO, and I look at that, I can see that that pod's not running, and there's actually an error there. And so if I go to my describe now, let's see, and let's go get that one. And I go to describe, I can come down here and look at the error, and it failed, and there was an error with the image pull. And it's saying right here, it's pulling the image was the issue. And it's because engine 22 doesn't exist. So you might get a question like that on the exam, and you'll want to be able to use that describe command to actually pull that. There's a lot of other different commands here. I think one of a very powerful command here is actually trying to getting the YAML code. So I actually might want to go ahead and create a pod and pull that YAML code as well. So let me see how we're doing on time. So we got about 30 minutes. I'm going to leave these for you as an exercise, but a lot of good stuff here. If I want to get rid of a pod, I can delete it. So let me go ahead and delete this pod here. That was a bad pod. So you might want to clean up a little bit and hit the delete, and that deletes it. And so if you go back to kget po. And this is what all I did for Docker Swarm. All day I typed in command line because that's how I interacted with it. Same thing with Kubernetes here. Okay. All right. Good, good, good. Any questions so far? We've covered a lot of information so far before we move on. Are you guys kind of getting a feel of some of the skill sets you're going to have for the exam?
Yes.
Yeah, so you're going to be able to work with this. I'm going to show you something even better than this. So we're moving on, but I wanted to show you some of these as a demo. I don't have time to go through all of them, but for the basics of Kubernetes, there's really kind of 4 things that are really central to Kubernetes. There's pods, replicas, deployment, and services. So that pod is the unit of scheduling in Kubernetes. It is a resource envelope in which one or more containers run, right? You don't want a huge amount of containers, typically 1 or 2 or 3, but not a whole lot because you're trying to decouple systems. Replicas ensure the desired state of pods are always they always run. So you may say, I want 3 pods, and if one fails, replica keeps it at 3. Okay, and then there's an example here on how to do that, and so we will get to that here in a moment. So we actually have a replica example, and then deployment is when you go to production, right? You want to go to production, and has anyone heard of a rolling update?
All the time.
Yeah. So
Yes.
you just don't want to just change everything at once, right? You know, and you want to have control over how you change things. So you might change a server at a time. So if something crashes, you can roll it back, right? Now, at the end of this presentation, there's something called Helm. And you, after you work with Kubernetes for a while, you will be running to Helm, because Helm is going to help you version your system and going to take, it's kind of a packager. It's a package manager for Kubernetes. And it's something you're going to want to use. We will have a presentation on Helm in the future, but not today. But I want to make sure I mention that. The other thing is a service, and a service enables communication between the various components within and outside the application. So you're going to be creating services so things can talk to each other. All right, and these are very essential concepts in understanding these. With that said, in one of the courses I think I mentioned, there is a voting app, and that's in the baby course. So if you go here, his simplest course that Mohammed Mumshad teaches is a 5-hour course. And he has a voting app example, which I think is just really nice, because it walks you through how the containers fit together and how they communicate and how the services work. And it even has, and putting the Docker in there in the pod itself. So I think it's a really nice example. With that said, let me say something about these Udemy courses. Wait for the deal. All right. And we're going to see that in a moment. His courses cost $129 to $134. If you wait for the deal, guess how much they cost?
$19.99.
Absolutely. Absolutely. You must have looked at the slide. But don't pay $124 for a course. Udemy is constantly every week running deals. So wait for the deal. So I don't work for Udemy. I don't get money from Udemy. So wait for the deals. Also, just want to mention there's also namespaces in Kubernetes. And so that's something I didn't have in Docker. And so you could create a sandbox, dev, and prod namespace and easily once promote up to the stack. Okay. Number of commands there to help you get started. Go ahead.
I think that namespaces are not a security space. It's just a convenience space.
Right. Thank you very much for mentioning that, Charles. Yes, there's a little more mechanism that you'd have put in to make it secure. Thank you. Thank you, Charles. Appreciate that. Yep. With that said, we got a demo. And what we're going to do here with this demo, this demo is a replica set, but we're actually going to go to one of Mama Beth's course, and we're actually going to see it through the course, what you're actually going to get when you pay your $19.99. 94 to get the course. So let me go here and go right to the course, and we're actually going to show you what you're going to see. All right. So this is actually one of the labs that you would see in the course. And I'm actually, let me go ahead and sign in.
Mike, I may have missed it, but when you buy the Udemy course, does that give you access to Code Cloud?
Absolutely. And that's
Okay.
and that could be, that's $100 value.
All right,
And
great.
and I was wondering, well, how can you offer that $100 value? And I realized he's the guy who created it, right?
Yeah.
Yeah. So that's a pretty sweet deal. And so, yeah. And so let me go ahead and go to the Udemy course, and then we're going to actually take a look at this cloud code piece as well. So if you go to Udemy, and let me do that. And if you just go type in Kubernetes, so you just do this in regular Udemy, his courses really have high stars. And so they're going to come up right away. And so this particular, and if you look at his particular courses, the way they look is that you'll go through and you will see lectures, okay? And then within the lectures, you'll have links to Code Cloud exercises. I believe in this particular exercise, I think we want to do the replica set. So let's do that. And what he does is he gives you free access when you buy this course. He gives you free access to the exercises. And I'm trying to get to that one. Here's the solution. Nope. Here's the hands-on. Let's go there. Okay, cool. And so you can click on that and it'll take you, hopefully this is the replica set one. That's what I'm trying to do. Okay, let me get on that one. And you can start the lab. And so this is a full-on Kubernetes environment. And you'll take a few minutes and it's loading the lab for you. And this is really nice. It's really sweet because I don't have to do any work here, right? So I just go here and I come home in the evenings, I just start, doing labs. And it's just a lot of fun. I mean, I used to do a lot of multimedia, and so I can animate fairly well. And it kind of reminds me of that. You just chill out and you start, typing in the command line. And so let me get off of this. And so it's going to start asking you questions. For example, so how many pods exist on the system? Well, let's go find out. And he's got K programmed in there as his alias. So, okay, get pods. Okay. And then you get that. And then how many pods do I have? Well, no resources are found. So 0 pods. Okay. Okay, get pods. It says no resources are found. How many pods exist on the system? 0. Okay, good. Must have been something, a loading problem there. So how many replica sets? So you're going to go, okay, get replica sets. So see how so it's nice because once you get used to the syntax, right? It's kind of the same, get replica sets. How many do we have there? Oh, none found, so that's 0. Oh, no replica sets. Okay, that works. And now they're going to set the system up for you. Just want to make sure you can run those basic commands. And how about how many replica sets now? Okay, so I can just do that back arrow, okay, and hit replica sets. And it says, how many replica sets do you think I have now?
You have 4 current, but 0 ready.
I would say 1. So it's just 1 replica set, but within that I have, yeah,
Got
I
it.
have 4 items. Yeah, absolutely. So yeah, and you can get stuck on that, and that's good because you know you do it here, you miss it here, you don't miss it on the exam, right? How many pods are in the desired state?
4.
4.
Okay, let's go with that one.
None are in the desired 4. You want 4 in it.
It's in, I think that's 4. Yeah, you guys are right. Now, there's a problem here. Okay, what is the image used to create the state? So what do you think I'm going to type in there? Anybody got an idea?
What's it? K describe.
There you go.
Images.
Images, yeah.
Let's see. K describe. Let's see.
Type grep minus I.
Absolutely, I'm going to want to grep it. Let's see. I'll try this. Let's see if this works. Yeah, I did a tab on that. So K describe set. I think that's good. And then I'm going to want to do it. Let's just do a describe, make sure that works. Good, that worked. So let's do it with a describe, right? So let me clear right here and bring this back to the top of the screen so you can see that. So what I did in the command, if you look at it, it makes logical sense, right? Let's go to it. K, I want to describe it. What do I want to describe? Well, I want to describe a pod, a replica set, or whatever. You know, I got to put what I'm going to describe, and the name in that, what I'm going to describe. Now I want to do a grep on that, right? So I'm going to do a grep minus dash I, right? And then image, right? Oh, fat fingered it. Okay, so we can see the image is BusyBox. What's wrong with BusyBox 777? Anybody can tell me? Right here, failed to pull BusyBox. What does that mean?
Well, the image doesn't exist. up
Absolutely,
there.
the BusyBox says so that there's no such image as BusyBox. There you go. All right, just go to the next one, and let's go ahead and clear the screen so we can see that. And so how many POs are ready in the replica set? So okay, get PO, right?
I think 0 last time we saw it.
But they set something up. So now we got here, but how many are in the ready state?
None are in the ready state.
Right, it's trying to create some. None. So what's going on here? So why do you think the pods are not ready? Let's look at one. Okay,
Because the
describe.
images, it's having
pod.
trouble downloading the images.
Yeah, let's take a look at them.
BusyBox. The image BusyBox doesn't exist.
Mhm.
I'm going to look at one of them. So I'm going to do the describe. I'm going to scroll down and see what, oh, there you go. Pulling image BusyBox right here, failed. It doesn't exist. There you go. The image that doesn't exist. Yeah. So, I mean, you know, this is a good way to just get repetition, do it over and over and delete any of the pods. So here's the replica set. And I believe that Ram, you mentioned how the replica set will bring the pod back up, right? So if I come along here, let's go ahead and take a look at this real quick. And I go, okay, get PO. And I look at that, I got 4 of them. If I delete one of them, what's going to happen when I check the state again?
It should try to create a new one.
It's going to try to make a new one. So it won't have 3. So let's go. Let's try it. We're going to delete that one. Remember that SRLT. Will I see that again?
Yep, you will.
I won't see that particular one. So I want to
But
go
you'll
get.
see another
I'll
one spin up.
So it's
Yep.
that one's gone, but another one has spun up, right? So there you go.
79GX is the new one.
Yep, there you go. And so it spun a new one up. Yeah, absolutely. So that's done. It says, hey, you did a good job. This guy's done a lot of work to make this happen. Okay, can you imagine how much work this guy's done? How many pods exist now? Let's take a look at this. K get PO.
Four.
You'll love these 4. Okay, let's go with that. Let's see here. Why are these still 4 pods even after you deleted one? Why after you delete one, why do you still have one?
The replica
Four.
set ensures
Yeah.
that the desired number of pods
Desired state.
always run.
Absolutely. Okay, there you go. All right, you guys are getting it. So this is actually fairly easy, right? Let's see if we can get something a little more challenging here. Create a replica set using that. File that. There are issues. So basically, I think they have one here in the background. So let's see what they have. They have a replica set already defined. Let's take a look at it. So what is that editor I like to use here?
VI.
VI. What's the joke about VI editor? I've been using VI editor for 4 years because I can't figure out how to get out of it, right? Dumb joke. All right, let's use one.
Well,
And,
that would actually be 6. That I have a friend
Yeah.
who calls it 6.
so this is what Kubernetes code looks like. It's YAML. And so if you're not familiar with YAML, you can easily go back between YAML and JSON. But YAML is kind of like Python. It uses spaces, right? So if you get the spaces wrong, you're going to get it wrong. And you're going to see it tells you the kind, which is a replica set, and it's going to tell you how many replicas you want in this particular one. It's going to have some labels, and it's going to have a spec. That's going to be your state. So it's going to tell me there is an issue with this. So try to fix it. Anybody have an idea what the issue might be? So if I want to change something, I hit I for insert, and now I can insert into this. And so where do you think my issue is? And you're going to see questions like this on the exam. Go fix it. Go fix the file, or go grab a file, or go, go work with YAML. You need to be able to do that.
Could it be its permissions?
In this particular case, you're close. It's not quite the permissions, but it's what it's trying to talk to in the API server. So there's various, places, and the right syntax for this is apps / for an epic. That would be for a replica set. So you're going to hit escape. You're going to hit colon, all right, and then you're going to hit WQ save, right? So there you go. And now I'm going to try to run this. All right. So let's see if if it wants me to run it here. I got an error, so let's try to run it. The way I'm going to run this, I'm going to use K apply -F, and I'm bring up that replica set. So I'm going to produce this .yaml. Let's see if it'll run. It was created. Now let's check it. And now it's running. So if I come along as OK, go K, get PO. Let's see if it's there. Oh, there you go. It's a replica set. The name should be replica 1. Let's take a look at replica sets. And then K get RC. Oh, didn't see anything there. There you go. There's your replica set right there. All right. Okay, I think that's good enough for now. Just kind of show you how this works, and if you buy those courses, there's 3 of them, and it's the same type of thing where he walks through, runs through labs. I actually did this basic course. I thought it was really good, and even though I have, and they say you don't need this course if you have experience with Docker and all, and I did, but I actually found it really, really, really fun and really useful. And then I went on to the developers course after that. So yeah, those 3 courses are out there. Everyone who's actually passing these exams are raving about these courses, and they're saying that they're the ones to take. So I would definitely put that on your appetite list when you decide to start working for this certification. We will do, I think I'm going to reschedule the Azure, push that down, and create a presentation just for prepping for this developers exam. Okay, with that said, I wrote some code for the deploy if you want to use that as a reference, or for services if you want to use that as a reference. And I want to talk a little bit about some links here, guys, if you want to actually follow that full Kubernetes path, right? So if you are working with a BA, or you're at the BA level, or you're an intro developer, then you should take that 5 hours beginners course, and then maybe the intro Linux or the KCNA. And I'll talk about what the KCNA in the next slide is, okay? And then if you really want to go to that Kubernetes engineering level, then you want to do that developer or admin course. And this is about a 16-hour course, about a 20-hour course, but it actually takes a lot longer to get through these 2 courses. Once again, if you look at the deals, the developers course was running at $124, and you can get it for $19.99. Okay, it's really, really sweet. And then you get free access to that particular course through CoCloud, which is pretty nice. They have a free challenge for Kubernetes on CoCloud, so you can do the free challenge. And then I think Calico actually contacted me. They actually want to come do a presentation. If you've ever been to the Calico site, it's actually used to support certain Kubernetes functions. And they actually have free certification. So you can actually go there to Calico. You can actually get involved in one of their training pieces and get a free certification once you complete one of their courses. If you have no money, that's a potential way to go. Helm is extremely important. It's the package manager for Kubernetes. You definitely want to learn Helm as you move on in your journey. And finally, I run a security guild at Great American. And so this is the CKS. This is the Certified Kubernetes Security piece. Definitely a course that I'm certainly interested in doing. Yeah. So and these courses aren't cheap. I mean, these certifications aren't cheap. They're like $300 a pop. So you're paying some money out here to do these. With that said, and all the links are here for you guys. So if you decide, hey, I want to go and I want to do the developers course, just click this link and it'll take you right to the developers course and you can sign up for it. And let's see here. They're running a sale right now. This particular course is $139 on any other day. Today you can get it for $19.99. And once again, I don't work for Udemy or do I even know this fellow, but he has done a tremendous job and everyone raves about his course. With that said, that's kind of the study thing I would do. I would also like to mention this. He has created another course that I found fascinating, and that is the Code Cloud Interview DevOps Interview course. So this guy is all about DevOps. And if you go here to the interview course, he actually walks you through, it's a pretty interesting course, walks you through all the elements of a DevOps interview and what you might be asked a question about Linux or a question about Git, or a question about Docker or Kubernetes or Helms or HashiCorp or Ansible. So, prepping you for that DevOps interview. So if you're looking for that big job, that might be a course you might want to take. Okay, with that said, we are getting close. Yes, we are. Let's see what we got here. What's left. I want to make mention of a few other things. Has anyone ran across Andrew Brown on the internet?
It is free on YouTube.
Andrew Brown is wonderful. He has all these free courses on YouTube, full courses. And I've actually taken a few of them and I've bought some of his courses as well. Now, what that means when you say buy, what he does, he has the course, the full course, all the training. And then if you want, I think supporting reference, like maybe a quiz or something like that, you can buy it. Okay. So it's really good. And he actually talks about getting into this business as well. And he says, if for the low end, if you're new to Kubernetes, maybe you wanted to take the KCNA, which is a Kubernetes and Cloud Native exam, which is a question exam. It's not a hands-on exam. And then you definitely want to move on and take that engineering track, either the administrative or the developer. And then he shows, as I did, the CKS, the Certified Kubernetes Security piece. So he kind of follows what I said. I didn't take this KCNA. I took the one that was suggested by the Kubernetes documentation trainer. I call it the baby course, and so I'm ready to go, right? With that said, we will be showing this in the next, I believe, in one of the next presentations when we do the Google and Terraform. We will be showing how to work with Kubernetes in the cloud. So basically, it's really easy to crank up in Google Cloud Platform, and our next presentation, we'll show you how to crank up Kubernetes in the cloud in Google as we prep for that Google engineering exam. All right, and then one last slide is my Helm slide. One of the problems with Kubernetes is there's no versioning. And so you definitely want to version your system in case you want to go back to something. And so you want to use that package manager Helm, and Helm has a lot of other features as well. So there's a great course here on Helm. I've actually taken a bit of it, and it'll tell you how to use it. So with that said, wow, that was a lot in an hour and a half. Don't you think so?
Oh, yeah.
The Kubernetes is the Greek word for helmsman
Yeah.
or pilot of a ship.
Yeah.
So that's why Kubernetes and Helm work together.
Because of the naming, right? Yeah, if you want to
Well,
deploy, manage, and yeah, go ahead.
It was deliberately named that way.
Yeah. So if you want to deploy, manage, and maintain, I mean, you're definitely going to need Helm to help you do that. Kubernetes can become extremely complex as you begin to build systems out. Yeah, well, there you go. I think that's all the information I have for you guys. Please does anyone else need me to paste the slide deck into the chat, or does everyone have it now? So please, please, please use these links to get started with Kubernetes. If you find anything else that I didn't cover, please let me know. If this is helpful, let me know. If you pass the Kubernetes developer exam, let me know. It's great to see that maybe I helped someone, and you guys have been great. Any more questions as we come toward the end? I'll hang out, guys, if you have any questions.